All right. Well, this is Supercharger game builds with MacStadium and Incredibuild. And what we're going to talk about today is how we're going to lower the ceiling for build times. And we're going to answer the question, well, what's faster, 4 low-end Mac Mini with M2 or 2 high-end Mac Mini with M2 Pro? We're going to talk about what we tested, how we tested, what we found, and what it means. To give a little bit about myself, I'm Matthew Pulsifer. I'm Infrastructure Product Manager at MacStadium. I'm responsible for infrastructure and Mac hardware products at MacStadium, so the Macs and everything but the Macs. 10 years in product management and solutions architecture, and I'm an avid Mac user.
And I'm Duncan Huffman from Incredibuild. I've started as a developer, moved on to product management and then product marketing for companies like Microsoft, AWS, Meta. For the last 2 years, I've been helping folks speed up their builds here at Incredibuild. And I'm super excited to talk about our new Mac platform today. So I really, really want to thank MacStadium for helping us and asking me to join. Thanks.
So, as I had said earlier, what's faster? 2 Mac Minis with M2 Pro are power pair. Each machine has 12 cores of CPU and 32 gigs of RAM, or the Fantastic Four, 4 Mac Minis with M2, 8-core CPU, just a basic machine, with 16 gigs of RAM.
So we should probably talk about distribution first. And one of the things that Incredibuild does, the heart of our system is our distributed computing. If you haven't experimented with it, distributed computing is a technique that takes advantage of available processing power across a grid of assets. In this case, we build a grid of your processing power. So it's not a SaaS product. You're not sending any data to us. We use the cores of your machines. So in some cases, laptops or workstations, servers, in this case, the Mac Minis, whatever you have. We use those resources as what we call helpers. So essentially, we have an initiator machine that has coordinator on it typically, and that breaks the build task into pieces and sends those threads to the helpers to build a giant supercomputer on the fly. So you basically turn whatever you have into a massive build farm. So, for example, if you take 10 machines in a grid, you take just 2 CPUs from those, suddenly you have a 200 CPU machine, sort of a magical HPC on the fly. I'll talk a little bit more about that. We've been doing this for AAA studios. Most game studios Epic uses this themselves, for example. We integrate directly with Unreal Engine, and we've been helping companies make great games faster for about 20 years. So we'll talk more about it, but I wanted to set the stage as to what techniques were used here.
So to go over our testing process, we came up with 2 worker node clusters and an initiator node. It's important to note that the build always runs on the initiator node in addition to the worker nodes that are enrolled in the cluster. So our initiator node, we went with a standard Mac Mini with M2, an 8-core CPU with 16 gigs of RAM. And for the worker nodes, we built 2 clusters, the Power Pair with M2 Pro and the Fantastic Four with M2. The benchmark that we decided to use was Unreal's Lyra starter game. As Duncan said, Unreal integrates really well with Incredibuild, so we wanted to see how we could possibly lower the ceiling, get builds running faster than they could run on any individual Mac that's currently available. We used Unreal Engine 5.2 and a pre-release version of Incredibuild for Mac, thanks to Incredibuild for providing that. The results that we're going to show represent the game build process only and not the packaging and other steps required for full distribution because we wanted to isolate it down to the distributed portion of the build. And these ran on standard MacStadium bare metal machines with 10 gigabit networking between the initiator and the workers, which is important because when you're moving large assets, you want fast bandwidth to distribute from that first node to the worker nodes. One of the things that's really neat about Incredibuild is that once you have the client added on the worker nodes, you don't have to add any additional libraries. Those are all distributed and run at time of compilation. So as a baseline, we're going to use a single node, and that's going to be our initiator node, but running without Incredibuild. So that's a standard Mac Mini with M2 and 16 gigs of RAM. That got us 18 minutes and 6 seconds, and that was executed directly with the command line using Unreal build tools. So just a single machine, we're at 18 minutes. The power pair, so we're running the two M2 Pros with the initiator node. We got 5 minutes and 8 seconds. So by leveraging a couple extra machines, we were able to cut the amount of time down by 3.5 times. And that's using Incredibuild. But what's interesting, so this power pair cluster has two 12-core CPUs, a total of 24 cores distributed plus the 8 cores on the initiator. But the Fantastic Four, despite having slower processors in all four of the machines, has a total of 32 cores. So we actually saw a faster result at 4 minutes and 36 seconds, 3.94 times faster than the baseline, nearly 4 times as fast. And it's just by adding more of that same base level machine. The last test that we did, we took the power pair and added the Fantastic Four to create the Super 6. So we're running both of our clusters at the same time, in addition to the initiator node. What's interesting is we did get a reduction in time by about just a little under 30 seconds for 5.6 times faster than baseline. However, you'll notice that for the additional Macs that we've added, you're seeing a diminishing returns. That's because of the initiator node, which was bottlenecking the process at this point. We looked at the graphs and we saw an increase in worker idle time. So these 6 machines and the worker node cluster combined, we're spending more time at idle. So it's important to make sure that your initiator node is sufficiently spec'd up to handle the amount of cores in the distributed worker nodes. The recommendation is about 5:1. So 5 worker nodes per initiator node core. The final results are quite revealing. Just by leveraging a few extra machines with the power pair, we're able to cut the total build time down from 18 minutes to 5 minutes. And the thing is that you don't need high-end CPUs to do this. You can just add more mid-range machines instead and still get similar scaling. Another 30 seconds down from the power pair for the Fantastic Four. And for the Super 6, I think we could get even better results if we put either a Mac Pro with or Mac Mini with M2 Pro as the initiator, or possibly even a Mac Studios initiator. We could build the cluster up to be a lot larger. It's all just about making sure you have enough initiator node cores. And that was the takeaway. More cores is faster builds. The power pair has 24 CPU cores total. The Fantastic Four has 32 CPU cores total, and the performance that we saw was directly related and correlated with the number of cores in the worker node cluster. The wonderful thing about this is that these machines combined are faster than the fastest Mac. And that's because we're using distributed computing, which can actually lower the ceiling for performance, lower times. But you need to ensure that you've carefully planned to manage bottlenecks, as we saw with the Super 6.
So I want to talk a little bit more about Incredibuild and what we offer. Matthew, thank you for those results. Those are great, and that's typical of what we see. The fundamental center of what we do is build acceleration. So we hate waiting for long builds, and I imagine most of the folks listening to this hate it too. And that's the problem we set out to solve. As part of that, we also solve some observability problems, and I'm going to talk about that in a second. And then sort of management and optimization, reporting, and automation. So we have these 3 legs, and they're really about the pain of long builds and everything connected to that. So let's talk about observability for a second, because I kind of hate that word. What I'm really mean when I say that is we visualize your builds and your pipelines in real time and historically on the fly. So if you've ever had to slog through logs and go line by line, sometimes as I have in the middle of the night, you know the pain of reading build logs and understanding what broke and who broke and how things are broken. One of the ways we speed things up is actually making that process real time and faster. So not just the distributed acceleration, but also the ability to see things and react to them. Color coded, you can see here on the dashboards that we have. You can double click on each thread and understand what's going on and what those risks are. We also integrate with all the tools you have for observability in your company today. So Grafana, Prometheus, Datadog, etc. We work with those tools. The bottom line for us is just making it super easy and exposing our APIs to make it super easy to integrate with the tools you already have. Automate things into your existing alerting systems if you have them, or if not, make it easy to access it in real time.
And anecdotally, I'll just add, these tools made it very easy to find where the bottlenecks were when we found that we were bottlenecked by the initiator, because we just saw more gaps in between individual tasks on each node. It was very visual, very easy to use, which I think is important when you're talking about creating a giant distributed compute cluster and figuring out how to most effectively use all of your assets.
We find that a lot. Even folks who aren't too worried about speed and acceleration, they really rely on these tools to understand who's doing what and how best to utilize the resources and investments they already have. What I think is the best part, in a lot of cases with these types of things, you have to learn new things. You've got to teach your teams new processes. We do this simply and non-destructively. So we integrate with your tool chain. You don't need to change your code. You don't need to change your tools. It isn't a new build system. It's not a new scripting language. It's your architecture and your processes. Most teams that we work with can get going in about a sprint. We work right from Xcode command line, and we also work from Visual Studio plugin, for example. We integrate with Jenkins, TeamCity, Git, however you work. We want to support that so that you're not changing what you're doing. You're just taking advantage of the hardware investments you've already made and really making your builds go wicked fast.
And as I'd said earlier, setting the cluster up was really easy, much easier than getting the build consistently building just by itself. Once I had that build pipeline set up in a way that we were happy with it and felt like it represented real world performance, moving it up to the distributed platform was as simple as putting ID build in front of the command. And I didn't have to install anything beyond just the Incredibuild client on the worker nodes, which made setting it up very straightforward.
Yeah,
All of the libraries and such are distributed at time of build.
we really do focus on that and stress the fact that even if you're in a compliant industry that has to worry about regulations, this is your stuff. You're not sending anything to us. It's your machines. You're just installing these clients and they're helping along the way.
To give a quick rundown of the offerings that we have available to run this on, if you want to set up a grid, these are our standard models. We generally recommend the medium and larger just because of the 16 gigabytes of RAM. And I believe for Incredibuild, you would want that anyway, because with games in particular, you're looking at larger and larger assets. If you're looking at doing a larger scale grid, I would suggest going with one of these MacStudio models, most likely the medium, to work as the initiator, because you want to make sure that you have 5 worker nodes cores per initiator node. So with this, the 24 core CPU, you can set up quite a few machines on that relative to what we ran into bottlenecks with on our 8 core CPU on the medium machine that we had used. But more cores is more performance. So you could set up a cluster with 4 M2 Pros and get even faster builds. It's all just a matter of how fast you need your builds and what meets your budget requirements. General takeaways from all of this: follow best practices. You want to minimize bottlenecks wherever possible. Having fast bandwidth between the machines was really important to ensure that these larger assets were transferred quickly. And we noticed that there was no real breakdown and bottlenecking when getting builds started because of that. If you were to use 1 gigabit interconnects and you're dealing with a really large project, that could be a problem. The initiator must be fast enough to keep up with the worker nodes. As I've kind of gone over in the past slide, studios are great if you're going to do a large grid. But if you take dedicated high performance Macs in hosted environment that is conducive to just high performance builds, and you combine that with Incredibuild, we can lower the ceiling on game build times and get faster builds than you could get with any individual machine.
That's great. I want to mention, Matthew, that you said you used a pre-release version of this. We're heading into GA rapidly here, actually, as we speak. But we're ready to get anyone going on Incredible for Mac today. So if you want to give this a try, it's available now.
And with that, we will open the floor to questions.
Looks like we have one about Unity. Yeah, Unity, we love it. So the bottom line is right now, Incredible for Mac doesn't support Unity. It's absolutely something that's on our roadmap, and we'll release some more information as soon as we have it on that. Really want to focus on that and make sure that that's part of the package as well. We've been doing a lot of work with the engineers over at Epic for a lot of years on their products, and we want to do the same for Unity. So we're focused on that now.
Another question, can you talk more about the signals you were looking at to identify bottlenecks? So in the actual execution graph that Incredibuild gives you, you can see the time it took for every individual task that got allocated to each worker node. So when you start seeing gaps between those tasks, it means that the worker node is idle, and that's usually an indicator that your initiator is falling behind in distributing the tasks out to the worker nodes. Getting some more questions in here. What are examples of tech stacks that Incredibuild and MacStadium usually work with?
It usually is an interesting question. So we just started working with MacStadium on this. They're basically our launch partner on this, and we really appreciate that. But maybe Matthew, you could talk a little bit about what you did here.
Yeah, so we decided to do this with Unreal. We are a hosting company. We don't usually do game builds, but we do benchmarks for Mac. And it's something that we spend a lot of time in trying to calibrate. So we make sure that we're getting the right machines for our customers, and that we can help represent the different models appropriately so people can make the best decisions. We went with Unreal for Incredibuild because Incredibuild is designed to do game builds in a lot of respects and high performance apps. Typically, MacStadium does a lot of iOS CI/CD, and when it comes to those kinds of apps, games are among the most demanding. They use the same frameworks and languages that Incredibuild is compatible with. So we felt that it was a good benchmark. However, this can be used to accelerate any C++ build process. Another question, can Incredibuild nodes act as initiator and a build node at the same time so the initiator can build after his build is finished? I'm not sure I understand the second sentence, but yes. Actually, the initiator has to be a part of the grid, which is
Absolutely.
why we saw more bottlenecks with the Super 6, because the initiator its tasks were prerequisites to complete some of the tasks on the distributed nodes. And when that was starting to fall behind the performance of the worker nodes, you started to see more idle times. So the answer is yes, and it must be. Typically, you want the initiator to be the machine that has everything installed to run a build by itself. And then you're just turning on Incredibuild and distributing it out to the grid.
It brings up an interesting point, though, that may not have been obvious from what we talked about. Incredible actually can take advantage of idle resources on any machine that you have. So if they're doing other things, we just take the idle resources. If they're not doing anything, they're dedicated to this, then we take 100%, obviously, as much as you want to assign. So we can dynamically use as much as possible. What's happening on the initiator is that machine's busy, and we're just taking the idle processes.
So no matter how you have your grid configured, the initiator is going to be a full-time build machine, more or less. But the worker nodes can either be dedicated worker nodes, or you can just distribute it across a wider range of machines. Another question, did you do any benchmarking on Mac Studios? We were trying to try and optimize for bang for the buck, if that makes sense with this. But it's a good question. If I were to redo this, I probably would have as one of the baselines, gone with a single Mac Studio with the M2 Ultra just to get an idea of what the fastest available single Mac can do, because I'm very confident looking at these results that at the very least the Fantastic Four would have been faster, and very likely the Power Pair as well, because it's the Initiator plus the M2 Pros. So the Mac Studio is effectively two M2 Max chips merged together, and the M2 Max is the same CPU capabilities as the M2 Pro with the 12 core. The difference is the GPU. So technically, you're running at 12 core or 24 cores, but you're comparing the 24 cores to the 24 plus 8 cores that you would see in the grid that we use because the initiator is part of the build. But
Uh,
yes.
I think that the short answer for me is if you have very long builds, you probably want to consider a studio for sure.
Especially as the initiator core or node.
Yeah.
We got some good questions today.
That's a great group.
With that, I think we're ready to wrap up.
I'm
Thanks, sir.
available on LinkedIn. You want to reach out to me, we've got a whole team who can help you sort of size what you need and troubleshoot what you're going through now and see if we can help. Again, Mac Incredible for Mac is available now.
And you can add me on LinkedIn as well. It's Matthew Pulsifer, and MacStadium has a wide selection of Macs that are all available on our website. Or if you want to set up a private cluster like we did here, contact our sales team. We'll set you up with a firewall and get a dedicated network so you've got a secure high performance build cluster for your games.
You should absolutely do that. We love it.